Okay, welcome to everyone. Hopefully you're in the right place for the R workshop. We are recording this, so if there are times I'm either looking at the camera or this frame you see around it has to do with the fact that we are recording things. I am hoping that between my knowledge and the knowledge of the people in the room, there will be enough background that if you're having trouble on something, you can ask for help. So please feel free to raise your hand on things if you have questions. I know Edward, one of the students in my lab, is comfortable helping people. Are there any other students in here who feel fairly comfortable in R and are willing to volunteer to help? Okay, Aiden, Ben, so all right. So first of all, I commend you guys for being here. Learning R, there's a lot of upfront costs, and it's really worth it in the end, but I know that it's not necessarily an easy thing. So props for being here on that front. I want to give you guys a few warnings initially, though. So first, I am not a computer scientist. I am not a programmer. I don't think like a programmer or a computer scientist. I was not taught in that way. The way I'm coming to this is as a political scientist and thinking about the things I had trouble learning and trying to help you guys avoid some of those pitfalls. So there's always going to be multiple ways to do things in R. Almost always there's at least more than one way to do something. I'm going to show you the solution that I have come up with. This is not to imply that that's the best solution to use. I learn a lot from my students who poke around and find new ways of doing things, and it would be really helpful if you guys share with me all of the things that you learn. I will do my best to try to explain some of the logic that underpins what we're doing, but I don't have a background in object-oriented programming. I can only share with you what I know. So those are the caveats. The encouragements here. So I imagine that most of you are probably here for a reason. You're either in my lab and I am making you be here, or you are here because you have some sort of data that you want to analyze or you foresee using data in the future. So always be thinking about how the things we're learning now could be useful to you down the road. Many of the things we're learning in this workshop, especially the two parts that we're doing today, are really kind of building block things. It's not that you're going to be able to do anything super cool with your data just based on what I'm going to show you here, but some of these things should help you so that you can do more interesting analyses and visualizations. I also encourage you to apply what we're doing today to your own data of interest as soon as possible. R is one of those things that if you don't use it, you can lose it pretty quickly until you get to know it pretty well. So yes, use it. And then please ask lots of questions. Don't be intimidated to ask a question. If you are confused about something, someone else is too. And this is a new workshop for me. This is new material, so it's very feasible that I am not explaining it as clearly as I could the first time. So I'm counting on you guys to let me know when you want me to back up or clear something up. Okay, so a quick fun challenge. Just stop and think for a minute based on what you know. Try and go through and jot down as many R commands as you know right now. So I'll give you a minute or two to be thinking through that. But try to think everything you've learned about R so far. You're aiming to get as many R commands as possible. Okay, so how many people think they can list 5 commands? Raise your hand. Okay, good. 10 commands? One handful. 15? 20? 25? Okay, anyone besides Edward? All right, awesome. So the point of this in part is that everyone is also coming in with a slightly different background level of knowledge. If you are sitting in here and you don't know anyone else, before you leave today, make sure that you exchange communication information with someone else so that you have contact for someone else who's learning. You can learn a lot from your peers. So during the break, maybe you can quiz Edward and see if he can list all 25 of the commands he knows. All right, so the first thing that I want to talk about is one of the uses that is most frequent, I guess, in my lab in terms of why someone would be using R. And R is a software package that's very well suited to analyzing the data that you might get if you have run a survey. And William and Mary has an institutional subscription to a program called Qualtrics, which is great in that it allows you to collect your own survey data for free, which is a really nice benefit. So the application that many of my lab students are going to be using this for is to use R to analyze the data that they're getting. So I wanted to talk about some of the best practices and being able to do that. So later this semester, the SSRMC will have a workshop on using this survey software program. But assume that you've already run a survey, that you've downloaded your data out of that survey program. And the first thing, the first rule of data analysis is always keep raw, clean copies of your data. And always keep duplicate copies of things. So when you're downloading something, make duplicate copies, save it something else, but always have that raw, unaltered data that you've exported. And the problem with doing anything to your data before you import it into R is that it's not easy to remember to always keep really good records of what you do. So when you're coding in R, you have your R window and you have your code window. And so anything that you choose to do, you're writing the code to go along with it. And it's an easy process for keeping track of what you're doing. But in Excel, there's no equivalent way of doing that. And so when you're doing it, you just need to be mindful about the process of what you're doing. I'm going to show you my preferred way for starting from messy survey data to getting it clean enough to read into R. But to do this, you need to be forward thinking in sort of what you want to name things and the changes that you make. So for those of you who have downloaded anything from Qualtrics or seen it, this is a screenshot of what messy data might look like. I sent you in that folder a document called Trial Codebook. And so you can pull up the trial codebook in Excel or whatever Excel-like program you have. And there are two problems with this raw data that are going to make it really hard for R to process initially. So the first thing is that there is this double header row. So R will read that in, but it's going to think of the second line as just one more row in your data set, and it's not going to realize that there's non-data information in there. And then the second thing is that there are all sorts of weird symbols in this data set that R is not going to be happy with as well. And so that might cause you complications. The third problem is that these variable names are not particularly interesting or informative, and so when you get to the point of doing your analysis, you're not going to want to have to think about your variables in terms of variable numbers. Oftentimes, you're going to have dummy rows in your data. So if you've previewed your survey or you've taken yourself a few times, you may have blank rows in the beginning that are easier to get rid of here. And then you may have unnecessary variables in there. These things are all doable in R, but I find it easier to do it in Excel ahead of time because it's easier to make a more descriptive code book. The danger of doing these things by hand ahead of time is human error. R will always do exactly what you tell it to do. It may not be what you actually want it to do, but if it's going to do what you've told it to do. And there's no good way to keep track of what you're doing. All right, so if the goal of the pre-processing in Excel is to essentially make a code book, you're going to use the copy and transpose functions in Excel. So some of you may know how to do this, and I apologize if this is repetitive for you, but here is my trick. on how I do this. So this is a snapshot of the data you might get out of Qualtrics. What I recommend doing is copying these first two rows, and on a Mac, I think on a PC too, it's the right click. You want to copy those, you want to make a new document, and then you want to paste special, and you want to say transpose. And now what you can do is add a new column here called variable name, and you can much more quickly define the variable names whatever you want them to be. So you want to be clear and consistent in your conventions when you're doing this, but I think it's much easier to name your variables here than going through and typing it in R. And the other thing is you can then save this as your first pass at a code book, and it's not a complete code book for a data set in the sense that you don't always have the full question and you don't have your answer responses here, but it's at least enough information to be able to move from the variables in your data set in R to the survey that you ran so you can flesh that more fully out. So once you've named all of your variables, you then do the reverse process. So you copy this column, and then you can come back over to your data set, and you can insert the copied cells. So it won't, I always forget to do this, it doesn't like having extra copies, so I'm just going to paste that back there. Come back over here, first put in a blank row. Now you can come and copy, and then go back to your original data set here. All right, so anyone have major issues so far with the Excel aspect of it? Of course, it's not pasting, but everyone clear on that? So once you would paste your variable name back in this top row, then you can get rid of the extra stuff here, and you'll read in a data set that has clean variables. Anyone want me to go through this again? Okay, so you have copied from your, all right, so go back to the original here. So this is the data you've pulled out of Qualtrics. You want to copy the first two rows, which are the information from Qualtrics about the variables, about the survey questions you had. So you copy those, and then in a new workbook, you would come over here, and you would, if you right-click, you can do a paste special, and you hit this transpose button, and that's telling Excel to take two things that were long rows and flip them so that it's a column. So I already did it, but you'd say okay. And then you would go through here and you would pick the variables that pick the variable names that you would, whatever you want to call your data. So, you know, name, date, age, whatever it may be. Then you would do the reverse process. So then you would copy this, then you'd go back to your original data set, and, sorry, before you would copy it, you would want to insert a row above here. Then you would transpose your variable name back into the top row. And then in here you can delete the columns that you might not want. Yeah, Dan?
When I open paste special, I'm not getting
Okay.
source.
Okay. Let's see here. So I think that may be, are you highlighting the whole column, or are you highlighting just certain names of it? Okay. What happens if you do just a portion of it like this? For the record, I don't particularly like Excel. I think there's lots of little finicky things like this, but it's still giving you problems? Okay, I'll come back at the break and we can talk more about it. That's the basic idea, but yeah, there can be some issues with it, I guess. Anyone else having another problem? Yes.
If you have numbers instead of Excel, does it still work? Because mine doesn't have a piece special.
I have no idea. Are there any other numbers users? There has to be, I mean, they made numbers to pair with Excel, so I would just, Google's your friend in this case, I think. There's probably a way, I would think. Okay, so you have, what you then have is a first pass at a code book and a data set with clear descriptive names that you can read in as your variable names. And that's at least a first pass of sort of trying to keep things organized before you go in. Okay, I wanted to show you guys a couple of other tips and tricks just to make using R slightly easier. So go ahead and open your R console so that you've got a blank window like this. And then if you go and anywhere, like here, I just have a folder on my desktop, but you can have any folder wherever it is. And any file, it'll work with any file, but it's most useful for files that you might want to read in to R. This works on a Mac. I don't know if it works on a PC, but if you drag the file, so right now I'm dragging it, don't move, I want you to just drag it over. If you just drag it over like that, in R, it'll now pop in the file path name for it. It'll save you some typing, especially if you're working with files that are buried in some sort of dense file structure in your computer. So you would still need to wrap this into the code. You still need to tell R that you want to read it in, and we'll get to that later, but it's at least a way to save you some typing on that front. Does it work on PCs? Any PC users? No? Okay. Sorry, one more way that Macs are better than PCs. Okay, the second thing is the question mark to get help. So if you type question mark and then a command that you want to use, it will pop up a help factor or a help window on this. The more you use R, the easier it will be to understand what's going on in here. But it's a useful way if you're getting error codes in a command that you think you know how you're supposed to be using. It's a quick way to see whether or not you're inputting the things you should be inputting. Okay, any questions about the pre-processing data in Excel or anything we've talked about so far? Yes. So I don't think it matters. I use the console just purely out of habit. I think that the RStudio, essentially the same thing. It's just your set of windows looks slightly different. So it's whatever your preference is.
Is there any difference between using question mark and help?
So like help, like this.
The question mark is a wrapper for the help command.
What does a wrapper mean?
It's just another way to call the help command inside.
Okay, so yes, it is the same exact idea. Yeah, Sabrina? Are you a Mac user or PC? We think it doesn't work on PCs. Yeah. Mm-hmm. Okay. Okay, so let's go ahead and jump over to R now. So you have your R window open, and go ahead and open the file I sent you called Advanced R Day 1. I use a program called Aquamax as my text editor. You can use R's native text program. R Studio, I think, has a window for your code. There are lots of other programs out there. One thing I really want to encourage you all to do when you get to the point where you are writing code for your own data analysis is to keep a good log of what the code you're writing is doing. So especially if it's an extended project where you're going to be analyzing multiple days, working on different parts of the projects at different times, keep good track of what this particular code is supposed to accomplish and when you were working on it. And also, I think it is a good practice to talk about how the part of the project you're working on here relates to some other part of the project. So it's just good for memory's sake to be able to sort of situate what you're working on. All right, so we talked about data preprocessing in Excel. And I want to talk a bit about alternate ways of reading in data. So if you did the online workshop, or if you use R and other for other classes or other projects or whatever, the most common way of reading in data, I think, is the read.csv or read.txt command. If you have something that looks like a data set and you are trying to get it into R, or not read.txt, excuse me, read.delim, if you're trying to just get your data set into R, that's the most straightforward way to do it. But there are a few other options, and if you use Stata or SPSS and you want to learn how to use R, but you already have a bunch of data that's in this other file format, one thing you might want to do is read in those other file formats. So there's a package in R which can allow you to do this. A package in R, I'm sure this is not a technical explanation, but the way I think of it is that a package in R loads in a bunch of new commands and new functions and new sample data essentially, so that R recognizes more things that you want to do. So the foreign package is for importing foreign data. You can either run this line here. If I run it, it'll give me an error, I think, because I already have foreign installed. So foreign is already installed. I don't know how you're supposed to know from this error message that the problem is that foreign is already installed on my computer, but it is. Does anyone who's not installed it have problems with this install packages? Okay, good. All right, so anytime you're trying to use a new package, you both need to install the package into the program, and then you need to load the package into this particular session of R. And so the command for that is the library command. And so I am bringing in the foreign package. And once you've done that, it will then give you information about different commands, so reading in Stata files. And this command will have different, it'll tell you things you might need to include to be able to successfully read in the file. Okay. Well, look at that. Thank you. I always actually do it, one of the few things I do in R from the top, but there is a package manager and a package installer, so you can do that as well. Okay, so so these, I didn't have any data from these other programs, but you can read these indirectly. You just want to be mindful of the differences in the conventions of SPSS and Stata compared to R. So they handle missing data in different ways, and you just want to make sure that you're telling R how you want to handle it. If you're reading your data in and it's looking funky, play around with some of those initial settings to make sure that it's reading in okay. Okay, so These instances so far, so the read.csv, the read.delim, and the read.dta or SPSS, these are all for reading in things that already look like data sets. But one of the things that's also useful about R is that you can read in things that don't look like data sets and then convert them into data. So one instance of this may be if you're working with text documents and you have a lot of text documents and you want to read them in and create a data frame from that, essentially. Or if you have, you know, any, I don't know, free response answers on something, or you've had people write short essays and you want to read all of the essays in. Any instance where you have something that you want to make a data set out of. Another example of this, in my lab, we collect physiological measurement, and so each subject that we run through our lab has a huge text file with data that we've recorded on them at every 20th of a second or something, and we need to take all of that, we need to read that data in for a given person, process it, and then we want to input it into a data set. So we're going to do a really small toy example of that right now. It's very small. I have 3 articles from a newspaper in a folder, and we're going to read those articles in, and we're going to grab some information from those articles and create a data set out of it. I know for a fact that this is not the best way to do this. I changed a bunch of this to show you some other commands on things. So be mindful of that. If you go talk to someone who does text analysis, they're going to have much more efficient ways to do it. But I'm just showing you one example of how this could work. If you're doing really large data sets, doing something like this is probably better in Python, but for smaller projects, R will work for that. Okay, so the first thing that we need to do for this example is define a function. Writing your own functions in R is a fairly advanced thing to do. I don't do it. It's beyond the scope of what I want to learn how to do, but it's really useful if you get into R. I don't expect you guys to fully understand what's going on in this portion. I'm just going to walk you through the general idea. So we are writing a function that's going to take in a vector of text. So we're creating a new command, essentially called the text edit command. And by creating this function, we're telling it that we'll be reading in something. And now here's all of the things we want R to do once we have read this in. So all of the stuff in here are all things to do with the processing of language. It's removing weird symbols out of text. It's making everything lowercase. It's replacing anything that might cause R to throw an error and be mad at us. It's getting rid of some of the extra white space. It's doing a bunch of things. And then at the end of our function, we're telling it we want you to return text, which you can see we keep rewriting over the text we inputted in. We keep improving it and cleaning it up and cleaning it up and cleaning it up. And finally, we're left with a clean vector, a clean set of text from what we read into it. So don't worry about understanding all the nuances of this, but for now, just copy and paste this new thing in. And you can play around with it. So, let's see if it looks like this. So, we've created this function. We're now running this function. The first time it yelled at me because I told it that it was looking for an object called JV123, and it told me that there is no object. So then I changed it to put it in quotes. And you can see what it's done is it's removed all the numbers, because we told it to remove those numbers, and it's made it lowercase. Okay. So we now have this little function that cleans up text according to some rules we wanted for this particular project. And the next step in what we want to do is we need to tell R where to go look on our computer to find all of these text documents that we want to read in. So this is where things can, you've got to customize the code we're about to put into the computer you're using, and whether you're a Mac user or a Windows user. But the first step, so if you just type the command getwd, it stands for get working directory, and this is going to tell you where R is currently looking for files. I think on a PC, are the slashes going the other way? Yes? Okay. So the first thing we do is we are creating a new object called working directory that is just that bit of the file path where R currently thinks we are. And then what you need to customize is pointing it to where these files are sitting on your computer. So earlier today I sent you a folder called Advanced R, and then within that there was a folder called News Text, and then within that was a folder called Unprocessed News Text, and that's where you want R to be looking for things, because that's where we have these documents sitting. So working directory is the base where we are now. The paste command is taking the things you're telling it to paste together. So we're saying paste together working directory and then the additional part of the file path. And then we don't want those two things separated by anything. Just nothing. So before you do the setwd, try just the paste command in the center part here. And you see that, you can see that it's now spitting something out that looks like the file path. And so we're saying we want to set our working directory, the setwd command, to that file path. And to check it, if you do, again, the getwd command, it should tell you that that's now where we are. Okay, so is everyone there? This is often where students get confused, so yes.
Yeah, I have an error message that says I cannot.
I think it's because you're not specifying the path. Correct. It's telling you you cannot change it because that thing you're trying to tell it to change to doesn't actually exist, probably.
Okay, where does the customize function?
So, are you on a PC? All right, so the slashes are going to go the other way. I don't know the PC structure enough, but it's like whatever it is to get to your user.
The slashes actually go the same way, but if you're in a folder and you're just copying over the directory, the slashes on Windows are not possible, so you have to go through and like change the slashes.
Okay, but where in that command?
So the command, what you're changing is this part here
Okay.
to specify how to get from where you were to where you're going now. Yes.
Where did you get that little piece that says like slash does not slash base? Did you drag that in from your folder? Like, how did you?
So in Advanced R Day 1, I have, this is for my computer, how to find the file. And you'll need to replace not this whole line, but just this part between the quotes here to match your file path. Get there. All right, so quick show of hands, who has been successful to this point? Okay, if you have your hands up, would you look around, and someone who doesn't have their hands up, would you go help them?
Yeah, so what I would do is just control, no, not shift, control. Hold on to the wall. So what you do is, you don't want to see, well, so.
But you still have to do it.
Yeah, I mean, I don't really know, I don't think there is like a place on.
Okay, yeah, that's. So, you need to. No,
Oh, yeah.
Yeah. What I did, did you like type it in the rest of
Oh,
the
yes.
Probably taste it from.
Oh, so we're not doing set WD yet? We're just doing fixed.
Or are we? At the beginning.
Okay, yeah, it's like a lot. Not like a
No,
lot.
no.
Oh, okay.
Yeah, we're not.
Minutes.
Yeah, and then from there. No, see, so you were skipping a step first. This first, page, first, I think we weren't. Was wrong.
So you send it to the next one, send it to the
Yeah, then you do. I'm gonna double check though, because then but I'm pretty sure you're supposed to do one then the other.
This is just extension of my upper stop. So it's basically saying set my action just file that's already with this.
Okay.
So what you
So.
No, we got the page so we can place for users.
No, I'm busy review. I'm like, oh, no.
That's all I have.
So you have to go through the
It's all
We got it converted smart. That's it. It's the instead of the. Maybe that's what is. Is yours on your desktop or is it?
Yes. Okay, better. Yeah. So that's a problem. It used to be where you're trying to be.
I don't think I'm. I don't know if that's fine.
Right.
So I just went to use that. Look at this. Is it everywhere?
So it's the unprocessed news folder that we're using.
That's how many grades are interested in.
Oh, yeah. You're in documents.
Okay, at this point, how many people have run it successfully? Okay, let's take 2 more minutes to try to get a handful more people, and then if you don't have it working, you can look over with someone else, and you can fix it during the break.
Oh, yeah, I mean, so this one. Yeah. Okay. Use that. So that was. Yeah. Oh, yeah, you even saw that. In your files.
Okay, so if you have not gotten that line to work, do not fret. Look over, share a computer with someone who does have it to work. We're going to be taking a break in about half an hour, and we will get everything working, okay? So once you have told R what working directory you want it to be in, the next thing we want to do is tell it additional information about the file names that we're going to want it to read in. So this next line of code uses the list files command, and it's going to list the files that are sitting in the working directory. So it's going to list the files in the folder where you've pointed R2, and we want to assign those things to an object called files. So if you run this line of code and then type your object name, which is files, it will return the names of the 3 files that are sitting in that unprocessed news text. So you know it's working if you got it to tell you that those 3 articles are sitting there. All right, so R now knows where it should look. We've created an object that has the names of the files that it should be looking for. And now we just need some placeholder objects that we're going to be filling in with information from those news stories. So wherever these things are sitting on your computer, let's just look at one of them. So we're in the news text. We're in unprocessed news text. And so just looking at one of these in a text editor, it's a newspaper article. Looks like there's some extra like formatting gunk up there, but it's the name of the article, the newspaper, the author, and then the text of the article. And so right now we only have 3 of them. A few years ago in my lab we were doing a project where we had 25,000 articles. And so you could imagine with 3, it's probably easier to just cut and paste into an Excel document the things that you want. But with 25,000, it'd be really nice to be able to loop through all of those and grab the information that you want from it. So for starters, let's say that we want, so we're creating a blank object that's going to receive all the text. And then we're going to want the text from that article. We're going to want the news service or the newspaper. We want to grab the headline, and we want to grab the state. And this is just a more efficient way of creating a bunch of blank objects. So you could also create all of these objects and just assign them to NA, but doing this in one line creates all of them as just blank filler objects. So go ahead and create those, and then you can look at them if you want, and it's just an object, just a thing floating around in your R environment that can receive information that you want to put into it. Okay. So the logic of what we're doing next is that we're telling R, we have a list now of, or we have a vector of all of the files, which are newspaper articles, and we're going to be running a loop. And the intuition of a loop is that you're telling R to do the same thing over and over and over, but you're iterating through something. And so in this case, we're iterating through all of the files that are sitting in that folder. And each time it's going to read in one of those files, and then it's going to be looking for particular things in the text to pull out. And then it's going to be assigning those into a vector of that like type of object. All right, so it looks something like this. We've got our newspaper article, our headline, and our author. We want to read this into R, and then we want R to find these things. And then we're going to be we created all of those blank objects. So we have a thing called text. And for the first article, we wanted to grab all the text, and we want to put it into the first space of text. So it's going to be a vector where each space in that vector is filled with the text from one of the newspaper articles. And then we're also creating a vector called, what do I call it, headline? Headline. And so this is just a vector that's going to be filled where each space in the vector is a headline from a different story. So we're creating these vectors of information, and then at the end, we're just going to smush them all together, and we'll have a data set. Well, actually, we do it the other way, but you get the idea. We're piecing together a data set by reading in individual things. Okay, so there's a loop within a loop. Loops are not necessarily the most efficient way to do this. If you're dealing with a ton of articles, we should talk about other ways, but for now it'll work. So we're basically saying for one in the length of files, so our length files, if you copy over just this length files part, is 3. It makes sense. We have 3 articles sitting there. So for k in 1 to 3, so we're going to keep changing the value of k on each iteration of the loop. First pass it'll be 1, then it'll be 2, then it'll be 3. And then we're using the read lines command, which is going to read in all of your text. So whenever you're running a loop, when you start building a loop, you always first think about what you would do with just one article. So for right now, let's go ahead and assign our indicator variable k. Go ahead and just assign k to be the value of 1. Can you guys see the edge over here? Sort of. Over there. Okay, so now anytime R sees a k, it's going to instead fill it with the value of 1. And so we will run through the inside portion of this loop to understand what's going on. So the first thing we do is the read lines command. And now let's look at what that did. So it read in the text. It looks like each line of the text is on a different line in this object called raw text. Okay, so if you run the next line, looks pretty much the same. I think this was an artifact. Oh, it replaces all that's different is it replaces this first line that was full of all those marks and has just replaced it with something blank. All right, and now we've got many commands bundled into one. So the idea of what we're trying to do is we're trying to pull out all of the words in this text. It's in this weird line format right now, and we want to pull out all the words. So when you've got a complicated line of code, you always start in the middle and work your way out. So this next line of code, the innermost thing is this portion right here. And what this is saying is it's the raw text object we just made, but it's only the 7th element of that to the last element of that. So length raw text should be 44, and lo and behold. So length raw text gets replaced in R's mind with a 44, and it's saying do all of these things from the 7th line to the 44th line of this thing we're feeding in. Now this is arbitrary just based on the structure of these particular documents that we're reading in. So whatever you'd be reading in, you'd need to get a sense for what is the pattern in this data. Where do in this case, where does the text of the newspaper article start? But that's in this particular example. Then we're running that text edit function that we made at the beginning. And remember, the point of that text edit function was to take text that had a lot of garbage, weird symbols in it and clean it up and simplify it. Then we're running a new command called string split, which is splitting apart a string object. And in this case, the string object are all the words. So it's going to split apart all of the words. and then it's going to unlist those. It's going to take all of those things, and string split will create a list type object, and we want to unlist those objects. So if you really want to understand what's going on here, I encourage you to play and do each bit of this to see how each aspect of the command works. Again, I'm using this to show you different commands, not because this is necessarily the most efficient way to be doing it, but if you now look at our text, it is now a vector where every line in there is the next word in the sentence, all cleaned up. And now we're going through and we're reading all of this text. So we're taking the first bit of it. So this is the first word in the article. And we're now running a loop to bring that text back in so that it's nice and cleaned up. So this is a loop inside of a loop. We're again using that paste command, which is saying take the first bit and the next bit and paste them together with what we want our separation to be. So, yes?
So in that one, what is I?
So I is another indicator variable. In a loop,
I didn't see the other
yeah, yeah, that's fine. It's a good question. So in this loop within a loop, we're writing, we're going to be cycling again through a new indicator variable. So if you run the whole loop, you do not need to set it. If you want to run one line within it, you would need to set it. Mm-hmm.
What's the line right above
It replaces that first line that had all those equal signs in it. It makes it blank instead. It's not essential. It's an artifact of the code I was copying. You can get rid of it in this case and it doesn't matter. Okay, so run this little loop. And now look at text again. And lo and behold, we now have a thing that looks like the text of the article. Now, if you were actually doing text analysis, the format of the text we just created is not particularly useful. You would want it all separated out to be able to do things. But if your goal is to bring all of these documents from outside of R and use R to pull them into a data set, there might be an instance where you want to have that block of text in there. All right, so we figured out how to get the text. Now we want to get all of those other elements that were sitting in the news article. So the state, the headline, and the commands here are, again, just telling R where to look for those particular pieces of it. So we're back to just within our K loop. If you look at the string split command, it's telling you first you put in a character vector of what it is that you want to split apart. And then split, you're defining the character it should be looking for in order to split things apart. So if you look here, we're telling it to string split the files object, but we only are looking at the second row of the files object. And the character we want it to look for is an underscore. So if you type in files, we're looking to split this file's name on this underscore character, and we want the second element of that. So we're asking it to pull this second part of it right here. Okay? And then we're doing that again. So if you run that and look at state file, oops, you got to run the line of code. So we're close to getting the state name. We now just need to get rid of that text portion. And so we're doing the string split again. This time we're telling it to look for a period as this character to split on, and it's just a weird thing in R that if you're using a period to split it, you need those brackets. I don't know why. Maybe someone else knows why, but yeah. So this time though, we want the first element. And so if we look at state, it pulls out Alabama. So we're pulling out, again, more extracting information here. And then you can see that our loop is ending right here. All right, what would be helpful to re-explain?
But I'm getting back there when I put in the state command. So when I do like state file, just get
Sorry, say that again. When you put in the state
instead of
command?
just having Alabama, I get NA.
Did you set K to 1, or did you run the loop?
I set I just copy and paste it.
Okay, I think at some point you probably ran something that created state as
Yeah,
NA, and then, yeah, that would be my guess. Okay, so let's go ahead. So whenever you're running loops, I think it's always better to run from the beginning because you can sort of create stuff. So go all the way back up to files and then copy all the way down to the squiggle mark, which is the end of your loop. So copy all of that over. And now if you look at the different pieces of this, they're the different pieces of things we would want in a data set. So the headline vector has the 3 headlines, the news service has the 3 news services, and the text is on a block in each of those. I'm really happy to explain any portion of this again. This is confusing to understand. I want to make sure you guys get it. So is there anything else that would be helpful to go over again? Mm-hmm.
So before I into so that's one loop. And then it's like a loop.
Yep.
So does before I into loop keep going until it stops and then the whole thing goes again, or like what's the order?
Yeah, exactly. It's a really good point. So in this big loop, the one at the top that says 4K and one of the length of files. So from there all the way down here is one cycle. And so within each cycle, it's then running a whole separate loop. Okay. So that is running each time we go through K. And then it's loading this text into that position. Okay, so once you've run that loop and you now have these vector objects floating around, state, headline, news service, text, those are the things we want to make the data set out of. And you can think of those vectors now. So we have headline, and the first headline, and the second headline, and the third headline. And then we have the text, and we have the first text, and the second text, and the third text, etc. And so we have all these things that look like columns of data, and we just want to smush those things together. And so the cbind command here stands for column bind, taking columns and binding them together. And then the as data frame command is changing the object type that cbind makes and making it an object type that is a data frame, which allows the difference between a data frame and a matrix is that a data frame, you can have multiple different types of data. You can have numeric data, you can have logical data, you can have character data, and you can also assign names to your different variables. So we're combining all of that together. And I know now, because we just made it, that news data is a little small data set, so it's fine to look at. And if you go up here, you can see that it's now all bound together. And then we want to assign names to it. So if we want to look at it without the text, we can look at just the first 3 columns. And the headlines are kind of messy. There's a lot of space in there, but you can see that we essentially have a data set that's all bound together. Okay. Okay, so here's what I'm going to say. It's a little earlier than I wanted to take a break, but I think you guys, I'm sensing that a lot of you are like nodding along that you get it, but that you actually need to do something to demonstrate that you do get it. So if you look at Advanced R Assign 1, so certainly take a break. Go stretch your legs, go get some water, go get a snack. But I encourage you guys to look at the first 2 questions on this assignment and figure out what questions you have about how you would answer these. And we will talk about that after the break. So we will plan to get going again at 5:25. I am going to float around the room and help. How many people still were having issues with the file path situation? 1. Okay, so then I will just be floating around, and please come grab me to ask a question one-on-one, to have me explain something again, to ask about an application of this. Take advantage of the fact I really am happy to answer any questions that you have. Okay, so I will see everyone back here at 5:25.
I'm sorry, could you just bring up your console just so I can?
Mhm.
Thank you.
Yeah.
And I made it like floral white, bridal blue.
I have like gold around 4, sharp 7.
I got the idea from you. I was like, dogs are blue. Okay. They're cool colors.
Yeah.
I put it in all these Reddit. Instead of taking notes, I was like, what's the weirdest color I can come up with are?
I'm so glad that inspired someone. Like I put so much work into that.
Oh,
I felt like
yeah.
nobody was going to appreciate
I
it.
appreciate it
I'm
so
so
much.
my I read the entire R documentation in color. Oh yeah, I read it.
So much fun.
Yeah, whoever wrote like the R color, like stuff, the PDF is like. The best structures. There are roughly 8 or 9 shades of structures in the art.
I just thought bridal white was my favorite thing ever. I was like, we need different white because there's also floral. No, it's not. Floral white.
It has a slightly, so it's technically, it has a slightly higher blue content, just so it like, because of rosin, it looks crisper than actual like straight peaches.
It made my thing so prettier.
It would have been awesome. It was made it seem like really easy to use it in coding. Right. And so thinking of it yourself, right?
Wednesday is fine.
Yeah.
Okay, so when you have that story, it's pretty very simple, Abby. So I broke my phone. I had to stop for a while, but I'm back. So I broke my phone, like completely, wouldn't turn on. I finally put the turn on and worked again, and then I lost it. But I lost it. So we're just like converting to my room, and I just saw my room, but I tried, it's hard. So I don't think it's good. Anyway, I don't know what I'm saying. Hi guys. I mean, I'm not good. It's not actually too much. It's just I don't know. It's like, well, right? Yeah, she was like the first you broke it. And you lost it. So you can't even get parts on it. And I was like, I'm very aware. Now it's anyway, I'm really
So it's like sitting there.
I did this last night.
Sometimes it's just why I'm back and solid. Oh, we need to take podcast here.
take classes at really online classes. So I figure I can get like 2 people to do it. I'm trying to. I might have to actually see. I like conceptually. I would say to get licensed to teach English, you have to specific. And I spent too long on it. So now I don't have time to go into the so I'm trying to get away with it. But my problem was on the 6 classes. Oh, and the problem with no, so I found it. I know. Now it's too late to dismiss, right? What I don't know is here she had new services online. She invited his the rest of the deal. So she got it before the you had to get it every yeah. I might go. I'm still. Oh. It is basically. But I also like want to and references to the presidency. So if you run it by itself, it doesn't know. And I'll probably come out with like 2 answers. Like there's some reason I would. It's like I don't know why it's not. So I would take a pass on it. So like rather than years, it's not. Get a master's in English law. Yeah. It took me a while to get the problem. I'm roughly figured out, so I didn't really. Did you call? I just don't know or why it didn't happen. But it wouldn't let me set a working directory. So I mean, if I had to already.
Yeah, there's like.
Yeah. Actually, so I noticed that you just said no, I would probably 3. But I did like impact news there. It was kind of weird. I don't know if that was wrong. Oh, yeah. Remember? Find state headline news tomorrow. Now. Yeah, we changed that one in practice. Actually, I think. Yeah, this is.
Yeah, so I think it's maybe.
No, wait, it did. I used the old big, yeah.
Unless it's bad, I don't want to. It's like
Right, right.
so that it's the longest one. I think that's probably.
Yeah.
Yeah. So that's
Is that?
don't worry, it's not. This was an example of showing that it's the end.
So the way she did, see how much she did.
There might be a way to fix it.
Alright, so you see, okay, so you see how on line. Yeah, the line is headline, that's the problem. So she's actually headline.
Okay, let's go ahead and get started again. Did anyone look over these two questions and have anything they wanted me to clarify? Yes. Is that the video? No. Yes. How is substring? Okay, so how would you go about figuring out how substring is different than string split? All right, so you could do help. So this may or may not be helpful to you depending how comfortable you are in R and how detailed it is. So substring, you're getting some sense, the same idea that you're feeding in a character, but then it's not necessarily super helpful in understanding that. Where else is a place you guys would go to get help when you're trying to figure out how to use R? The interwebs, more specifically. The R project website has some information on there. Stack Overflow is useful. The Quick R website is useful. Honestly, if you just Google R substring, like something will pop up and will lead you to where you are. So R's internal help is most useful for understanding if you're put in a command and it's throwing an error, it's most useful for trying to figure out the technical bits of why your command may be going wrong, what other elements you need to include in it. But the internet more broadly is going to be a much better place for conceptually understanding the differences between commands. Okay, what else? So I'm not going to tell you the difference, but you can now be empowered to go find that difference on your own. Okay, if you are able to do number 2, I think you understand what we did on the first pass, on this first part of it. Because being able to do this will require you to understand how to create an object to receive this new information about the date, how to use the substring command to identify where that date information is, and how to bind in that information at the end. So number 2 here will be a really good test of whether or not you conceptually understand the first part of what we did. I can't emphasize enough to you guys, I really encourage you to work on this over the next week. You can email me, I'm happy to meet with you. You should email each other and work on it. But if you don't test yourself on the material as you learn it, you're going to delude yourself into thinking you understand more than you really do. So really put your skills to practice while you have the chance to be in this workshop and communicating with other people. Okay, so it's good practice at the end when you're done working with a particular data set to remove the object. We created a bunch of other objects. Technically, you could either completely clear your workspace or remove all of the things you don't want. It's not a big deal to keep things in there, but best practice probably means to sort of clean out what you can. So we are now going to be switching and talking about other things you can do to more traditional looking data sets. The more you do in terms, so in my lab, in terms of running surveys, those of you who have honors theses that involve surveys or whatever the case may be, there's a lot of things you can do on the front end of your data collection to make processing in R easier. But sometimes you don't know, it's a trial and error process. You don't know that that the way you're coding something in Qualtrics or the way you've had your data coders enter the data into what they're doing or whatever it may be, you won't know that you've created some problems for yourself until you've done it. You have to figure it out in R, and then you can think about how to not create the problem in the future. But one of the things that happens in survey experiments, for example, if you're running a survey experiment, there's a way you can program it, and sometimes you have to program it this way, where respondents, based on what treatment they're receiving in your experiment, have been assigned to a different block in the survey. And then when you export the data out of Qualtrics, they may be answered the same questions, but their answers are all in different variables depending on what treatment they received. So I'm going to show you how I remedy this situation. Like I said, the best way to do this is find a smarter way in Qualtrics to program it, but sometimes it's unavoidable. Okay, so you're going to read in these CSV files. Let's see if this throws an error. Okay. The reason here it didn't throw an error is because I'm specifying again the file path where it should be looking. So even though my working directory, we're still sitting in the unprocessed news text folder, you can tell R to read in files from somewhere else on your computer. So again, you'll need to customize the part that you put in quotes here to tell R where to look to go find the file. So some of the problems it seemed like people were having the first time is that the zip file I sent you, it was, when you unzipped it, it would duplicate advanced R, so you may have the advanced R folder sitting inside an advanced R folder. I'm sure, is the squiggle convention the same on Windows? No. So this won't work. So at risk of more chaos and reading in files, was everyone able to read in these two files? Yeah? Okay. Excellent. If you like the user interface thing, go with RStudio, and then it's a little bit easier to get stuff in. Okay, so MT1 and MT2 are two portions of a survey. And so if you look, so from the first R workshop, remember that anytime you're reading data into R, you always want to get a handle on it. So what are some of the commands you can use to get a handle on your data? So table can work for a particular variable. STR. I don't think that'll tell you about initially. It might, down the road, it could be useful potentially. Yeah, so summary, on a big data set, summaries can get kind of messy. Yeah, Emily? Yeah, so head or tail is one option. So the first thing I always do is just dimensions. The reason I always do this is because it is the cleanest way to tell you how big of a data set you're working with. And before you do any of these other things, you want to have a sense for, if you're going to ask R to print out something for you, how big of a commitment are you investing in its printout, right? So we know now with 1,900 subjects, 1,900 rows in this, that looking at single vectors of 1,900 values is okay, but probably too much bigger than that you wouldn't want to. And printing out this whole thing is going to not be fun, right? 30 columns of it. So once you know the dimensions, what's another thing that you can look at before you look at head or tail? What's another really important piece of a data set? How do we know what variables are sitting in here? So the list does something else, but your intuition about asking it to list things are right. What do you want it to be list? What do you want it to list? The names. So in R, to get your variable names is the command names. And this will now tell you the variables. And now, if you want to get a little piece of it, you can use the head command for the first 5 rows, or the tail command for the last 5 rows, and get a sense for what your data look like. So in this particular survey, subjects were answering, they were assigned to a treatment group, they looked at a treatment, and then they all answered questions, or answer 1, answer 2, and answer 3. But the way it was programmed into Qualtrics means that there are sets of answers here depending on which treatment group they were in. It doesn't actually correspond to this treatment, so as confusing as that may be. Anyway, okay, so this here is looking, it's another kind of compound command, but we want to look at the vector of information for the a.answer1. So the is.na command will tell you, it's a logical vector, a true-false command about whether or not the position in the vector is NA, is missing. When you put an exclamation mark in front of it, it means you want to flip that so that it becomes true if it's not NA. The which command means return only those ones which meet the condition. So in this case, return only those which are true for not being an A. And then the length command is the length of the vector that meets those conditions. So when you put all these together, copy them over, it's telling you in the first one that there are 615 subjects who have an answer for that variable where it's not an A, 288 for the other, and 1,023. Now you could know going into it, or you could observe that this adds up to the length of our data set. So every subject in here falls into one of these 3. All right, so the goal here is we want to analyze everyone's data. They were all answering the same questions. So we need all of their information to be in the same columns, to be in the same variables, the same vectors in R's language. So we're creating now new variables at the end of the MT2 data set. So if you do that line and then look at the names again, we now have a new variable on the end. And I always just learned it's best practice to create your variables and fill it with NA first. And now what we need to do is move everyone's data for those questions into the same columns, depending on which set they're in. So notice for the next 3 lines of code here, we are just filling in for that first answer, but we are specifying conditions as to which positions in that vector of data, that variable of data, which ones we want to fill in. And the condition is the same on both sides of our assignment operator. So we're taking the same set of conditions. And the reason you do this is because if you try to fill a vector with something that is not the length of the vector, R will not be happy. And so you need to be filling a vector of the same length as to what you want to fill. And so we're saying into our new answer1 variable, for all those cases where a.answer1 is not an A, same information here, fill in a.answer1, but only in those cases when it's not an A. So if you run this first line here, and then look at this, you'll see that data has been filled in, but we're still missing 1,311 cases. And that's because we haven't filled in data for the people in these other conditions. So the next round, we are, again, still filling in answer 1, but this time we're filling in for those people who do answer the B portion of it, and then here for the C portion of it. Now the reason you do it like this, the reason you want these conditions is if you just fill in, if you were to fill in without the conditions here, you'd be overwriting your vector each time. And so at this last part here, you'd end up with a vector that was only reflective of the people in the C.answer group. So we can try that actually. So we ran it now, the first, actually let me do this. So if we don't put those conditions in, we're basically just saying fill our new variable with our old variable. And if we look at mt2 a.answer1 and mt2 answer, it looks identical, right? So then if you were to run it again without the conditions, it's now going to look, oops. So this is now the second one, and if we tell it to do this, it now looks exactly just like that. It looks like the B version. So the conditions in here tell it to move only the information that is pertinent for the variable you're trying to move, so that you end up with a complete variable based on these 3 different variables. That make sense? So if we wanted to start and create answer 2, what is one change I would make to this code here to start creating our new variable for answer 2? Is that a hand, Jonah? No. So where would I do that? Yep. So the first thing you need to do is specify that you're now creating this answer 2. What else would you change?
In the which statements you have to change all these.
Yeah, exactly. Okay. So the question then is, so maybe you don't want to just create 3 new variables based on their answers. Maybe you just want to create a summary index. And so you can imagine right now that Okay, so we have 3 columns here. People are sort of like this. Right, so they've either filled in their answers in the set for A, or filled in their answers for the set for B, or filled in the answers for the set for C. You might want to create a new summary that is just the sum total of their answers, and you just want to fill in all of this data. The quick way to do that, so again, we're creating a new variable here. The quick way to do that is the row sums command. And so it's saying sum across the row. And it's just counting. So if in our data set, the rows and, the columns in question are columns 18 through 26. So I know that from over here that we want to be combining 18 to 26. And so the row sums command is saying, all right, go ahead and just sum across those rows. R doesn't throw an error. You might think that it looks just fine until you want to see a summary of it, and nothing happened. It's still filled with NAs. So, see what happened. This is where the help or the question mark command comes in. If you look at the default setting in this row sums, it's saying that the default is that NA remove equals false. And so basically what's happening is anytime it is seeing an NA anywhere in the columns it's trying to sum across, it's saying, oh, I shouldn't count this row because there's an NA in it. And so it's skipping it and going. But in this case, that's the very thing we want to overcome. So by adding this command at the end here, it's overriding the default, and it's saying, no, don't remove those NAs, go ahead and include them. And now if you look at it, it looks like we expect it to. Now, this can be dangerous in the sense that you can create variables that aren't meaningful if you don't think about why the data were missing in the first place. So in this instance, we have a really clear understanding of why these data were missing. They were missing because the subjects in our survey were either channeled into one block of the survey, the second block, or the third block, and they had no opportunity to answer the other questions. And so that's fine. We're very comfortable with that. But if you're using this to try to make some sort of summary index of something, so say, all right, so there's a 3-part efficacy battery here. And if you were to row sum across this and say, yep, don't worry about those NAs, just go ahead and add them up, it means that people who skipped one of those questions in the 3-question battery are going to have really low scores on that final summary variable, not because they actually had lower political efficacy, but because for whatever reason they didn't answer one of your questions. And so you as the researcher have to make the decision about whether it's appropriate to include people with missing data at the risk, of dropping your N considerably if a lot of people didn't answer a question, or of overriding that default and creating a variable, but not necessarily knowing why someone might have a lower score on it. Okay. Okay, questions on this bit? What can I explain further? Mm-hmm.
What was the purpose of creating at the bottom what was the purpose of creating the
This part?
Yeah,
So I think the reason I was taught that it's the best practice.
I don't need to do the edit stuff. That's
Oh,
all good.
down here?
Yeah, right below it. So, why do we want folks to do that?
So we want to create these because we know as the researcher that the same answer 1 was answer 1, whether they were in group A, group B, or group C. And so we want to create a variable that gets everyone's answer 1s so that we can analyze something about answer 1. Yeah. Other questions? Okay, so another thing that you likely will want to do with your data are merging and matching data sets together. So there's a few sort of warm-up commands that are useful. The first ones are sort and order. Sort and order are easily confused, but the difference is that sort is used on single vectors, whereas order can be used to reorder a data frame based upon the order of a particular variable. So, in a data set of this size, so remember there's like 1,900 respondents, normally I wouldn't recommend printing out an entire variable, which is what's going to happen when I ask it to print the age vector, but sort it. But it's just a number, and there's only 1,900 of them, so it won't be too bad. So, you see with sort, it is just printing out all of the values of that variable. The respondents on this survey come from Mechanical Turk. The modal Mechanical Turk respondent is like a 24-year-old white guy living in his parents' basement, I think. So you see a lot of younger people on here. I really want to know, I want to know the 70-year-olds on MTurk who are just like making money, taking surveys. It's kind of I know that my parents would not be that savvy. Anyway, okay, so when you sort, the default for sort is to sort in increasing. Again, if you look at the information here, decreasing is false, meaning that the default is for it to increase. If for some reason you want to override that, you just add on this extra portion here within the command itself, and lo and behold, now it goes decreasing. Okay, now there's not typically a reason you would ever just want to be sorting your variables. Looking at a variable like this is not an informative way to understand the distribution of a particular variable. But something like this kind of command is really helpful as a building block for things down the road, like if you are plotting something and you want things to appear in your plot in a particular order. So I'm teaching you this not because in and of itself it's particularly useful, but because we'll come back to it later. Okay, the difference with order, remember that sort is used for vectors, order is more useful for data frames. So when I put order in, I get all of these random numbers that do not look like appropriate ages. What this is the position order within the age vector for each respondent. So this one here is that the age of this particular respondent is 16th in the order of ages. This one is 34th. This one is farther down the road. So if I do like this, so I'm repeating this, but now I'm only going to have it show us like one line of it. And so this, well, that's not a great, what do I actually want to do? I want to do MT1, age 1 through 10. Okay, so you begin to get some intuition here. So the oldest person in the first 10 people for this variable is 51, and they are farthest down the position vector here. Is that right? I think that's right.
What is the sort?
So the sort is reordering the ages of all of the people in the vector. And so these are not the first 10 people in our data set. These are the first 10 values of the sorted age vector. This is a vector of the actual ages of the first 10 people as ordered in our data set right now. And this is their position number in the sorted age vector. I think that's right, Jonah?
There's a 53-year-old who, by that order, is younger.
Yeah, I'm not explaining this correctly. Give me a second here.
He's lower down the list.
Yeah. So this one, what is order doing? I'm going to come back to this because I'm not explaining it correctly, but let me keep going while my brain works in the background to figure out what I'm explaining wrong, unless someone sees immediately what I'm explaining incorrectly. Okay, let me come back to that then. Okay, so let's look at, these are the first 10 rows and 10 columns of our data set. If we wanted to order them within age, we're now asking R to rearrange the whole data frame based on the order of the age here. So it's totally going to rearrange the data. Okay, so it is reporting back the row number. That's what it is. It's the row number of that person based on the way they were originally sorted in the data frame. So in this reordered one, where we've asked R to reorder the data frame based on age, it's now ordered on age, and then the default goes to the ID number here. And because in this data set, the ID numbers were just numeric, starting at 1, going all the way down to 1,926. That matches the row number as well. And it's the original position they were in the data set, based on their order, based on their ID. So that's what explains this up here. That's what's reporting on here. So, you can also tell it to reorder based on more than one variable. So here, notice now that first we're telling it to order on age, and then we're telling it to order on the gender variable in our data set. So it's going to go through all the 18-year-olds, but first all the men, and then all the women, and then all the 19-year-olds, first all the men, then all the women, and so on. Okay, so again, you probably won't need to order just for the sake of ordering. But another best practice thing is that if you are going to be merging data sets, it's always safest to order the two data sets you're trying to merge on the variable you're trying to merge them on. So R is going to do its best to overcome that and like figure out the merging, but it's just best practice to order your data set before you do. Because merge, it's not all, like I just find the merge a little bit harder to fully understand everything that R is doing. I tend to use the match command, but they're very similar commands. The idea with merge is that, I mean, I think you guys are familiar essentially with that. The word merge makes sense. The idea with match is that you are matching in data from a new data set that matches based on the linking variable you're telling it to. So the nice thing about match is that you can do one-to-many matches. Does that make sense? So we'll do an example of this later on. I find match a little bit more flexible and it's a bit more precise as well. But option 1 with merge. Okay, so first, just to get a handle, I always recommend before you merge things, just get a sense for the two things that you're pulling together. And then the merge command asks you for the two files you're going to be merging, and then by the variables that, or by the common variable that you want to bring them together on. You do not have to have the variable in the two data sets be named the same thing, but if they're named different things, you have to specify the name of the variable in each one separately. Whereas if they are the same, you just use a single by command. And then the other thing that's important to pay attention to is this all portion. So in this data set that we're using, I know that there are the same number of respondents in the first one and the second one. But say you were doing a survey where you were doing one round this week and you wanted to do another one after the Iowa caucus, and you're targeting the same people, but you know that not the same people are going to respond because there's going to be more drop-off. So you'd have two data sets and they're unequal sizes. You'd want to tell it to keep all of the respondents in the first bigger data set. So you would want to say all.x equals true or all.y and drop everyone else. All.y means keep only the people from the second data set. And then all, if you said all equals true, it means keep all of the people from both data sets. So you have to think about what you want your final one to look like, whether you only want it to be people who responded to both, whether you want it to be the everyone who started out, and so you want a data set that ends up with NAs for people who didn't complete it, or just all means both sets. I didn't explain that very well. Do you guys get the idea of all? It's basically telling you which ones to include in your final new data set. Yes?
So the merge command generally, are you trying to add new variables to one data set and keep the same units of observation, or are you trying to add new units of observation and keep the same variables?
So the units for merge, the units of observation have to be the same in the data sets, but you can have more of them in one or the other. And so the idea in merge is bringing in new variables, and the all aspect of it, specifying the all, tells you which sets of rows to keep.
So, as an example, like you would have, or I guess this is probably the example we have now, you have one survey and then another survey of the same respondents with different questions.
Yes. Okay. Yep. And so that's the more common thing, where you have a larger X data set and then additional information on some people. But there, you could imagine an instance where, so for example, has anyone in here participated in the Omnibus project? Has anyone participated in more than one semester of the Omnibus project? So we could identify the students in common, and we could say we want all of the students who've ever participated, or we only want the students in common that participated in both of these semesters. Okay, so let's do a little test here. So the dimensions of the two data sets, there's 16 variables in the first and 34 variables in the second. When we merge together to create a new data set, how many columns should we expect in our new data set? Close, but not 50. 49. Why should we expect 49? Exactly. So it's adding the column to the one to the second and minus 1 because there's the duplicate variable. So it's good to think a little about what you should expect. You can then run it, and lo and behold, that's what we end up with. Now the other nice thing about merge is that it brings with it all, if you can type correctly into R, it will bring with it all of the variable names automatically. You can also merge just subsets of the data. So say you only wanted to grab one other portion and fold that over, you can do that as well. And you do that by specifying which columns you would want. You could also do it with which rows, but that would be an unusual way to use merge. Okay, something like this, it's pretty straightforward, but I do encourage you, as you're learning R, always double check your work. Don't assume just because R didn't spit an error at you that you actually told it the right thing. So one thing that's nice to do is check, here was the variable in the original data set, and here is the variable in the combined data set, and you want to make sure these things match because that means that everything worked okay. Okay, the other way to do this is the match command. Match can work similarly to merge. You just have a little more control over what you're telling it to do, or it can be used for a one-to-many. I think that's the way it works. Okay, so we'll skip. So this one is really boring because these two data sets are ordered in the same way, so the ID variables, but remember that we reordered one of these. And so the ID variables, it's the same people, but the ID variables do not match in the order that they're in. And so the idea behind the match command is that you're telling it to say, take the elements of this vector and tell me the position that they are in for this other vector. So here, and notice that the order in which you tell it which to look in which, it's going to be different. So these next two lines of code will not be the exact same thing. So I'm going to, if you do it, it'll print out all of them. I only want it to do the first 10, for example. So the numbers it's spitting back are different because it's the relative position in the second vector of where in the second vector you can find the elements of this first vector. And you can see here, so for example, it's saying that the ID number that's in the first position here should be in the 492nd position in this vector. Or sorry, it's the, I always confuse it. It's the other way around, I think. Yeah. So the first ID number in MT2 is number 1, and it's in the 492nd position. Is that make sense? Are you guys following this? I'm getting tired. Okay. So MT2 is ordered by ID number. So when we ask for this element, it matches the same element here. But when we do this match command and it's telling us 492, it's because in the second vector, the 492nd position of that is where you will find number 1, which is the number in the first position of that vector. Just trust me on it. I was doing what it needs to on this one. Okay, so the key thing is always just to make sure you're matching in the right order. I tend to create a new data set when I'm matching, so I'm going to start with one of the data sets, and I'm going to create a second, just an identical object right now, but so it looks the exact same. And then I'm going to create an object called column length. And so this is the column length of the current MT1 reorder data set, or the MT total 2 data set, minus 1. And the reason I do that is because when you're matching in, you are matching in variables to essentially append to the end of your data set. So if we have MT1 reorder, which we now are calling MT total, we've got all these variables, and its dimension was 16, I think. And we want to match in the new variables, and we want to put them, we want to start lining them up in the 17th position, and then the 18th position, and the 19th position in this data frame. So we have a data set MT total 2 is 1,926 rows and 16 columns, right? Our ID variable and then 15 columns of information. And we're trying to match in information from another data set, and we want to match it into the space that's appropriate. Okay, so we're aiming to match into the 17th column. The variables that we want to match in from MT2, we don't want to rematch in the ID variable. So we want to start matching in the first informative variable from MT2. And so we don't want to match in the ID, we want to match in starting here and going all the way to the end. So from 2 to 34. So here, this is just asking for the second dimension, so the 34. So we're looping through all the variables in MT2 from 2 until 34, and we want to match them in to the end of the MT total 2 data set here. Now, the match command is in the row position. So we're taking the MT2 data set. In the row position, we want the order to be matched in. We want it to match the order of the first data set, right? MT total 2. And so there's an error in this code here. So see here when I renamed our data set to make a new data set. You should replace this with that. It doesn't matter because they're identical, but you should change it. So we're basically saying take, this is the order of the ID variables, find the order of them that will match our MT2 total, and then loop through each of the columns we want. And so we're matching in new variables ordered to match the data set where they're going to be arriving. And we're looping through this. This is just to tell it to arrive in the 17th position. So we're looping from 2. We're starting at 2. we want to land in 17, and so that's why we do this, in order to have it add 15 every time. So if you run all of this, and then check what you're doing here, you'll see that it matched correctly. It should have matched correctly. I don't know that it did. Okay, I am seeing, yeah, Emily? This one? This one? This one? Yeah, so we're setting up a loop. We're telling I what values we want to cycle through. What we want to cycle through are the informative columns from MT2. So the informative columns are from 2, so they're going back up here, from 2, column number 2, to the last column, which is 34. So you could replace everything that I've highlighted right here with 34, but as a general rule, you don't want to hard code your data more than you need to. So this will always return whatever your dimension, the length of it is, the number of columns that you have in your data set. So we're looping through all of the columns in our second data set, matching in the data in the order of the IDs from the first data set. And you can again check this out and make sure that it worked okay. Okay, one last thing, and then we're going to take a 5-minute break where I'm going to make everyone stand up because people are getting sleepy. The other thing that match is useful for is the one-to-many. So there's a data set here. It was in that same folder. It's a data set that assigns prestige to these occupations, whatever they are. And we can match in the prestige based on a person's occupation. So we have the occupation variable in the survey, and we now want to add in this other information from this other data set, MT-OCC. So we are in our data set MT1. We're creating the blank variable, and then we are moving over the prestige information, but we're creating a index of ordering of what that should look like. So if you look at this, all the numbers in here are between 1 and 12. And it's referencing the position of the prestige variable here, and then it's moving over the equivalent. So it's saying, all right, we have this prestige variable, which is right up here, and we're now matching. And so in the first one, the value of prestige that should be moved over is in the 11th position because the person's occupation was number 11. For the second one, the person's occupation was number 4, and so they're moving over in the 4th position the value of 80. That make sense? Okay, we are taking a break. We're almost there. 5 minutes, and if you didn't understand something about what I was just explaining, because I don't think I explained it very well, have a question for me at the end of our 5-minute break.
Like, you should do some stuff on it, like,
I had a question about the image for the treatments that we've been emailing about. You mentioned in the last email that we were kind of going back and forth about it, and you said it should have a partisanship connotation. Do you remember what I'm talking about?
Yeah, so the buttons, like by having blue and red and having things that look recognizable as partisan buttons, I think that will like make people sort of think they're all about right. It's about Democrats and Republicans, but it's not going to be a flag, so it shouldn't activate like patriotism. We basically want them to be. We want the image to match what they're supposed to be thinking about, but not prime anything that it shouldn't.
There's one of the treatment groups is supposed to be not priming to think about group dichotomies or whatever. Would that be a problem? That was the main thing.
I don't think so. I mean, it's a pretty generic thing, right? Like these buttons. I don't think it's not like there's going to be a red button and a blue button, right? I mean, it's sort of just vaguely American without,
And then I can say something. What should the button say? Do you have any idea what direction?
Should. That link I sent you used to like blue and red,
Like a star or something?
yeah, like nothing. You don't want to. Nothing that looks like a flag. Nothing that no on your elephant. Just like red, white, and blue. But or something like that.
Yeah, something. Yeah. Okay. Cool.
Yeah. Yep.
I'll figure it out.
Okay.
This was all your code originally, I know, on like our own modules, and I just still haven't grasped it. Why, when we're creating a variable, do we load it with NA? Because if you don't do that, it still works.
It's because there are times when you are filling something that is not the same as what you're. It's a safety mechanism so that your vector you're filling is the right like you're creating a fill vector that you know is the length of your data set. And it's filled with NA so that if you're filling something else in here, it's hard to find out an example. Say something like this. It would be when you're matching in something else. If you have it filled with NAs and there's not a match, it's filled with the NA already. You're not.
So it has all the NAs for like 1926. Yep. And then you're filling something else in, but if they don't have enough NA, or
if there's no match, for example,
okay,
it'll have an NA in it already.
Okay.
That's not a good example. Let me think about this.
Okay.
I understand why there is a reason, I'm sure, from the computer science side that I don't know. And then I know I hit this, and I'll just try to remember the next time I hit it.
Okay.
Why we do it, and remember to tell you about it.
Okay, thank you.
Yeah. Okay, has everyone at least stood up, stretched something, a little bit more awake? Okay. All right, so I want to back up for 1 second just because I was seeing a lot of blank stares and I want to make sure you guys understand this. So why, when we use the match command, here we're having the variable, the ID variable from the first data set and then the second. And here we're having from the second and then the first. What is the difference between what we should expect when this command is run, these two different ways? So same command, same two vectors we're inputting, but the order in which you line them up matters. So how is this thing different than this thing? Take a stab. Essentially, we're creating two different reference vectors. So what we're trying to do here is understand the relationship between the elements in two different vectors. And sometimes we want to know the position for the first, in the first vector, where you find the elements of the second. And sometimes we want to know in the second element where you'd find those positions in the position of the first. Now, I always confuse these things, and I'm fairly certain I confused it even explaining it the first time. So the only trick, this is the way I remember it. When I am getting to the point where I'm actually matching something over, I am matching from this data set, MT2, and I always remember that that goes in the second position. So the thing you are matching from, that goes in the second position, and the thing you are matching to goes in the first position. Okay, so we are in this instance lining up the orders of the variables in MT2 in the order as they should appear here. Okay? Mm-hmm.
I'm a little bit confused about why you need a loop there. Are you basically doing the command for each column?
Yeah, you're cycling through the columns. So merge is just like, okay, take these two data sets and smack them together, right? Match, you are bringing over, you need to bring over every vector individually. And so the loop accomplishes this. The I in this case is looping through the variables in the second data set that you want to add to the first, as opposed to matching over every single variable from the second data set into the first data set. Good question. Now, I did some things in here that I think are potentially confusing, right? So we renamed, we created a new data set. And that is just a habit I got into so that I didn't inadvertently overwrite on my old data set. So if in doubt, duplicate your objects so that you don't, so when you mess something up, because you will mess something up, you don't have to start over and read something in. So by doing this match on a duplicate object, if you do mess something up, you haven't messed up your original data over here. And I did this here to help you guys when you're trying to replicate this code so that it can be more generalizable. So you know that you're always looking for the length, the number of columns in your receiving data set -1 when you're looping through so that you line it up right when you're matching in. Okay. Okay, I'm very happy to answer more questions about this. If you want to stew on it and play around with it and we come back to it next week, I'm happy to do that as well. All right, now one thing you may notice is that the variable names did not transfer over when we used match. And so you need to name the variables you've created. And the way you can either do that as part of your loop or after the fact. And you want to be taking the names from the data set you matched over and putting them into the name slots of the receiving data set. So we were moving from MT2 into MT total 2. So the basic structure is going to look like this. But we don't want just all the names. We want a particular set of the names. So starting here, we want to be subsetting some portion of the names. So what numbers should go in this position here? So this is the data set from which we were pulling the variables. And so the hint is that it's the same two numbers that we were using in our loop. So in our loop, we were looping from the second variable in MT2. And what was the last thing we were pulling through? The last one. So if you don't remember that number off the top of your head, how could we figure it out? So 34. So we want to pull the second variable name to the 34th variable name. And what are the column numbers for where that set of variable names should be placed into our new data set? Oops, sorry. Yep, 17 to 49. So we can figure this out a couple of ways. The obvious one is that R elected to make its own variable names here. So there's a difference between what we were calling it and where it starts automatically naming things. But you could also reason through it. Remember back on the board over here when we were deciding where to match in, our original data set had 16 columns and we wanted to match into the 17th column. And so we know that 17 is where we need to start. And then 2 through 34 is 32, is that right? 32 new columns, so you could do 17 plus 32 to get 49. And lo and behold, we've moved all the names over.
So in the original data set, column 17, 49.
They didn't exist. Yep. Okay. The last thing here is just a useful operator that's conceptually related to these things. There is a name for it, but my quick Googling in R, I don't know. It's just the percent and percent operator. I have no idea what it's called. The idea is you are taking a vector and then you are finding out which elements of that first vector appear in the second vector. So the first vector is that, and second vector is that. And so what this will print out is a logical vector, so a true-false vector, of which of the elements in this first vector also appear in this second vector. So it will be false if it doesn't appear and true if it does appear, and it will be 6 in length. So when I run this line, what should we expect to see? Jacob?
False, 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 true, true, true.
Very, very close. Yeah, you're on the right idea. So it's going through.
1 through 4, so it's false, 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 true, true.
Yep. So it's saying of the numbers between 1 and 6, how many of the numbers between 1 and 6 also appear between 5 and 20? And only 5 and 6 appear in both, so they get the value of true, and 1 through 4 get the value of false. So this is another one of those things that just randomly comes in useful when you're trying to do other stuff. So if you're ever trying to figure out sort of which elements of one vector appear in another, remember this little guy. Okay. The last couple of ideas I wanted to cover are things related to reshaping your data. So taking, you have one sort of base data frame and you may want to reshape it in other ways. The first thing I'm going to show you is something that's really useful for social network analysis. So in this data set, there are variables here, and the respondents named a friend and then assigned a score with how frequently they talk about politics with that person. And so they were asked to name 2 friends and to evaluate them. And in social network analysis, you might want, instead of thinking about your unit of analysis as the subject, the respondent to your survey, you may instead want to think about the dyad, so the subject-friend pairing, in which case in our current data set, every row has 2 bits of information. It's not, our current structure doesn't match the unit of analysis we're actually interested in. So we want to create a new data set that matches our unit of analysis. So the easiest way to do something like this, I think, unless you're doing this with a massive number of columns, is to physically grab the columns you want and stack them in the ways that you want. So right now, we've got a data set where you want 1, 7. Okay, so we have data like this. We care about the first column, so that's our ID variable. We care about the friend 1 and friend 1 evaluation, the friend 2 and friend evaluation. And we basically want to stack these 2 things on top of each other, including the ID variable with both. So what we want is something like this, where you have the ID number, the friend, and the evaluation. And every subject would appear twice. Every ID number would appear twice because everyone rated 2 different friends. So what we're going to do is first grab the columns we care about. Just make this other object called friend data. Then you're going to grab just the information for the first friend. So the ID, friend 1 name, and friend 1 eval. If you look at this, that's what we expect. We want to assign, so the key thing with the rbind, the rowbind command we're going to use later, is that the column names have to be the same. And the column names should be renamed in that we now are generalizing away just from friend 1 and want to be thinking about the name of the friend and the discussion frequency more generally. And now we're grabbing the information for the second friend. So again, we want the ID variable, but this time we want columns 4 and 5 instead of 2 and 3. We then need to make sure that we rename them the same thing. And then you just stack them on top of each other. So as expected, it's now twice as long as our original data set because everyone is in there twice. But our unit of analysis has changed so that we're now looking at the subject friend dyad. There are lots of applications for this with lots of different types of data. So I encourage you to think about the data you have, whether you work in A data in some capacity or are taking other classes, to think about this idea of how you might have multiple observations on something for your original unit of analysis that then translates where that is what you want the new unit of analysis to be.
So if you did like tail, if you did tail command with the IDs naturally.
Yeah, no, that's a good question. So the tail of the second one should match the tail of the combined one. Because you're just stacking, we made an object called dyad 1 and then dyad 2, and we just stacked them on top of each other. Okay, there's another way to do this, and honestly, these packages confuse me so much. Every time I try to use them, like I just get confused. So I'm showing you the basics of it. These are really common ways to reshape data when you're shaping from wide to long format. So wide format, for example, if you have longitudinal data or time series data on something that you originally collected in wide format, where you have, again, multiple observations, and you want to make it long format. So you want to, where each row in your data set is, for example, a person's response at a given wave of the survey. So you've got to add quotes, as Ben pointed out here earlier. So if you don't already have it, you need to install it, or you can reinstall it, and then you need to load the Reshape2 package. And then the core commands for this are melt, cast, and recast. I read somewhere online, I think this is not a good way to think about it, but the way they said to think about it was melting. It's like you're melting iron and it drips long, and like casting, you're casting, I don't know, I didn't get it. Apparently melt and cast are intuitive to some people, but they're not intuitive to me. So the big thing with melt is it's moving from wide to long, and you need to specify what the ID variable is and what columns you want to pull along with it. And so if you compare this to, so notice now that in the melted data, we've created a new variable, creatively called variable, that tells us which of the old variables is associated with the value. So if you look at a table In our newly melted data set, we have 1,926 observations of friend 1 eval and 1,926 observations of friend 2 eval. But they're now stacked on top of each other, and we just get the values here. We could do the same thing and just get the friends pulled over. And then so what I don't this is what I was trying to figure out and I just couldn't. There has to be a way to do this in one step. I just couldn't figure out, so where you are able to pull, somehow combine so that you're getting name and score, but I couldn't figure it out. So then this step then is combining again the value from the two different objects that we just created. So this looks like what we were doing the first time, but using slightly different commands. So if anyone wants to poke around with the Reshape2 package and try to explain it to me/us, that'd be great. I don't find it all that intuitive, but it's a very common way to do this. Okay, last thing for the evening is X tabs. It's very useful for cross tabulations, but it's also useful for getting kind of quick summaries of your data. So we're going to this combined data set, and we're asking it to summarize the friend 1 evaluation based on the friend name and whether or not the respondent was male. So, any guesses what this is spitting out at us? Hmm? Okay, so Megan is halfway there. So on the left are number 1 is the male respondents report. Number 2 is the female respondents report. We have it broken out by friend, but those numbers are not counts of the number. They're something else. What are they? So we've accounted for friend 1 over here. We've accounted for male here, so it's got something to do with friend 1 eval. So what could it be? Yeah. Exactly. So this is adding up all the evaluation scores of Allison by males and by females. So females are more likely to report frequent conversations with frequent political discussions with Allison than are males. Okay, what is this one? So let's break this apart. So what are we getting at here? What does this which command tell us? Mm-hmm. Yes. So how many times is in the friend 1 vector, how many times is Catherine named? If we just did which, it's going to be a logical vector of true, false, as to whether or not friend 1 is named Catherine or not. And we don't care, that's useless. But the length tells us how many of those conditions are true. And that is information that's useful. So that's the number of times Catherine appears. In case you can't tell, I totally made this data up just by simulating stuff based on my friends' names. So unlikely that in a survey of Americans, that many of them would have a friend named Catherine. Okay, what's the difference here? What is this one telling us? Mm-hmm. Yep. And notice that 383 is the total of 254, and 129. Okay, and you could do the same thing looking just for males. Okay, X tabs, if in X tabs you put in this logical condition, so equals equals, asks are, is this condition true? So if you do this, it's asking, this is giving you the count of how many males named them. It's similar here if you do a table of two different variables. So this is how many men named Allison and how many women named Allison. And you can explore if instead of just calling the output and having it printed to the R screen, you assign these two different things to objects. You can see that they have different properties. So one is just a single vector, one is a table. If you do names object 1, it prints out the names here. If you do names objects 2, doesn't like it. So there are times when X tabs can be used to pull out useful bits of information that you might want to make a plot, for example. And plotting from an X tabs object might be easier than plotting from a table type object, for example. Okay, this was a lot of information. The assignment that goes along with this should help you sort of test your knowledge on this. I can't emphasize enough, please email me with questions, please reach out to each other. While it's fresh in your mind is the best time to work through it. If you're feeling really lost right now, which is okay, what I encourage you to do is go back through the code and break apart what we were doing line by line and look at the objects we created. If you're looking through the loops, don't run the whole loop, just look at like the meat of the loop, so to speak, like the stuff we're actually doing inside of it, and try to understand each line by line. And I'm really, really happy to help. I can't emphasize that enough. So I can stick around for a few minutes if you have questions right now. My lab, I will email you out the assignment information for those of you who need guidance on that. I think that's it. I will see you guys next Wednesday. We are downstairs in some classroom down there. Thank you guys for your attention.